So yun, good morning. Ito yung presentation sa Harmonics. So yun, first, ano nga ba yung Harmonics? Harmonics is an electrical circuit. Harmonics in an electrical circuit is the distortion of fundamental sinusoidal waveform supplied by any source. So yun, nandito yung example. So makikita natin, sabihin natin ito yung ito yung output ng rectifier o yung mga diodes. Usually, pag yung ideal sinusoidal waveform na inaasahan natin is yung green. Yan yung ideal waveform or ideal sinusoidal waveform. So, pag i-apply natin yung principle ng harmonics, yan yung kulay pula. Yan yung mga distortion na sinasabi. Kasi in real life, hindi naman ideal, hindi naman halos or hindi naman totally na-achieve yung ideal sinusoidal waveform na kulay green. So yan. Cause of harmonics. Harmonics are caused by loads like controlled rectifiers, AC and DC variable speed drivers, solid state heater, rectifier transformers, zero switching transformers. Also, linear loads can cause harmonics during starting. Capacitor switching also cause harmonics. Presence of harmonic in applied voltage aggravates the effect of harmonics in capacitors. The root cause of harmonics is nonlinear current drawn by loads even after applying linear voltage waveform. So, yung nonlinear current na sinasabi niyan is yung mga nilalabas ng three-phase transformers natin. So, ito naman yung effects of harmonics. Waveform distortion resulting in components of higher order frequencies. Yun. So, yung distortion baga is yung madaming curve na kulay pula kanina. Pag madaming ganun, ibig sabihin, mag-iiba yung equation ng sinusoidal waveform. So, magbabago-bago din yung frequencies dun sa equation. Loads are designed to use only fundamental frequency. Other components of frequency are lost in form of heat both in source and load. So, pag madaming distortion na nangyayari sa isang, sabihin na nating power supply, pag madaming distortion or madaming distortion, ano yung mga forces hindi masyadong na re-reciprocate. Yung parang hindi lumalabas as an output. Kasi nga hindi siya ideal. So, yung kung papasok is yung 60 Hz, yung lalabas, hindi siguradong 30 Hz, mga ganyan. Kaya baga makikita natin sa mga rectifiers, yung niya, yung output na nakalabas, parang may estimate mga, sabihin natin sa 55 to 65, mga ganun, kung sa 60 Hz na power supply. Kasi nga, hindi natin sure kung ano yung lalabas. Parang hindi ideally. It also causes heat loss in cable, circuit breakers, and power factor improving capacitors. So, yun. Parang ganun nga. Also, the extent of distortion in voltage waveform depends on the following: total harmonic content in load, size of the source. Same nonlinear load will have different distortion of voltage waveform if it is running on DG set or infinite source like grid. So, yun sa total harmonic content load, ito na yung mga iba't ibang order. Mamaya, i-explain natin yan. Doon naman sa size of the source, ito naman yung sinasabing iba yung distortion na nangyayari sa power grids, yung sa mga transformers na malalaki, kaysa dun sa mga transformer na makikita natin sa power supply. Magkaiba yon. Pag mas malaki yung size of the source, or ibig sabihin, pag mas malaki yung transformer, mas madaming distortion doon na makikita. Kaya magkaiba yung distortion sa power grids and sa variable power supply. So, yun. Importance of harmonics. Harmonic study and correction allowance is necessary before installing any new source to prevent premature failure of power factor improving capacitors, overheating of transformers, overheating of source alternator, which causes increase in active losses. These are supplied from prime mover, result in higher specific fuel oil consumption. So, yung unang example is yung premature failure of power factor improving capacitors. Ang ibig sabihin nun, katulad nung nasabi na kanina, which is kung ano yung power na pumapasok sa input and yung ideal na lalabas sa output, hindi siya nga pasok. So, kailangan natin magbigay ng allowance. Pag magamit tayo ng power supply, mga ganun, kailangan ng allowance ng output. So, yun, overheating of transformers. Pag mas madami yung distortion, mas madami yung heat loss, tas parang hindi mag-aakma yung power nila. So, yun. Tapos ito din, overheating of source alternator. Ibig sabihin naman ito, pag yung alternator baga natin is yung mga generator, pag gumagana sila, pag hindi akma pag madaming distortion dun sa stator at rotor, or dun nga sa buong generator, mas dadami yung consumption nila ng oil, mas mag-use sila ng fuel. Ganun. So, kailangan maintindihan yun. Next is, presence of switching harmonics also cause differential relay to operate during switching of power transformers. For example, ABB SPAD T46C relay has the provision for filtering the second and fifth order dynamics. So, yan. Ito na. Next slide. So, yan. So, harmonics, ito na yon. So, we can mathematically split the non-sinusoidal waveform in sinusoidal waveform of multiples of fundamental frequencies. So, yung una, hindi ko pala nalagyan ng label. So, yung fundamental, which is yung kulay green, yan yung ideal sinusoidal waveform natin. Yung third order naman, ito yung makikita natin sa mga ito yung parang ito na yung achievable in real life, yung third order. Kasi mas pasok siya dun sa fundamental eh. Saka pag padami yung sinusoidal waveform ng isang power supply, sabihin natin, which is ibig sabihin madami ng distortion. Makikita nyo naman eh, yung fifth order is yung kulay blue, yung dark blue. Tapos yung ninth order is yung kulay pink. Tapos yung 13th order is yung kulay dilaw. Yan. So, ang achievable in real life is yung third order. Tapos yung fundamental, which is yung green, is yung ideal. So, yan. Harmonics do not exist separately in a system. So, ang ibig sabihin nito, parang ito nga ang ibig sabihin nga nito is, dapat yung harmonics, yun na mismo yung system kasi isa lang naman yung nilalabas. Next is, harmonic analyzers are used to detect the magnitude and order of harmonic. Yung harmonic analyzers daw, yun yung isang apparatus na ginagamit para ma-detect kung anong order kung makikita kung ayos pa or sira, ganun. Para ma-detect yung allowance. So, yan. The effect of harmonics can be reduced by oversizing of source. Yun na nga. Alternator transformer. Use of suitable harmonic filter. Yan, mamaya discuss natin yung filter na yan. Use of phase shifting techniques to cancel the harmonics. Yung phase shifting technique, hindi ito ma-apply sa lahat eh. Parang na-apply lang ito sa mga controlled yung specialized na controlled locations, yung mga grid lang to meron eh. Wala nito yung mga power supply, yung nag-change ng phase. Usually kasi may isang phase lang yung mga transformers natin. Pero pagdating sa malalaki na dun sa mga technicals na, tulad ng power grids, tapos dun sa generation, meron na silang phase shifting techniques. So, ito na yung harmonic. Wait. Harmonic filter. It is the inductor capacitor LC circuit. This LC circuit is tuned for absorbing the specific order of harmonics. It offers low impedance path to bypass earth-specific order of harmonics and also offer high impedance path for that order to pass to the load. So parang ano siya. Kumbaga sa saksakan, para siyang adapter. Parang ganun. Para ma-adapt nung component para magtama yung sinusoidal waveform na ini-exist nung output mo, tapos i-connect mo siya sa isa pang component para matama. Yun, parang ganun. So yun, in summary, harmonics are the part of today's modern electronic loads. So, sabi nga natin kanina, in real life, wala naman talagang di naman talaga naglalabas ng mga transformers ng ideal sinusoidal waveform. Usually, third or fifth order sila. So, yun. We cannot avoid them as they are related to the total plant efficiency. So, yun. Gaya na nakalagay sa importance kanina, kailangan natin pag-aralan yung harmonics para makapagbigay tayo ng allowance dun sa. Next is we need to measure them and take corrective actions to avoid power loss and premature failure of components. So, ayan. Para hindi maiwasan yung power loss and yung fuel consumption sa mga auto transformers and synchronous generators is efficient. So, yun lang. Thank you.